Hello and welcome. My name is Christin Kreutz. I'm a PhD student from Trier University, and today I'm going to present our paper, Diverse Reviewer Suggestion for Extending Conference Program Committees. This paper is a joint work with Krisztian Balog from University of Stavanger and my PhD supervisor from Trier, Ralf Schenkel. Scientific writing heavily relies on peer review. Peer review has to be conducted before papers are published. With it, we strive to ensure validity and soundness of papers, but also to give feedback to the authors of these papers. The overall goal here is to assess quality of papers and to have reliable reviews of papers. Here, automatic assignment of reviewers to papers is conducted. Let's look at a general problem of automatic review assignment. This problem is mostly considered for conferences where we have multiple submissions at once in a tight time schedule. We are given all submitted manuscripts and a set of possible reviewer candidates, the program committee, or short PC. Our goal is to automatically assign sets of suitable reviewers to all manuscripts. Currently, PCs are formed before manuscripts are submitted, and thus the problem of a possible mismatch between these reviewers and submissions arises. This problem could be overcome if PCs would be extended after the submission period ended and before a review assignment is conducted. The novel reviewer coverage task observes exactly that. We introduced the reviewer coverage task. It consists of the well-observed review assignment task, but also contains a reviewer suggestion component. The goal of the review coverage task is the assignment of suitable reviewers to all manuscripts and to ensure diversity of the PC. Review assignment constructs suitable review sets for manuscripts of a conference. The review suggestion part recommends new reviewers to be added to the PC. Both components influence each other, as we see here on the right. With the review assignment, we can identify manuscripts which are still possibly lacking some suitable reviewers. So, reviewers fitting the requirements of these manuscripts can be recommended. With the new suggestions, we can then ensure diversity and suitability of the assignments. So, when we talk about suitable reviewer sets for manuscripts, we consider these three properties. Reviewers should have expertise in the area of the manuscripts. There should be no conflicts of interest between assigned reviewers and authors of manuscripts. And global reviewing load constraints cannot be violated to prevent overburdening of single PC members. These properties are already observed for the review assignment task, but they also hold in a broader review coverage task. So, as the overall result of the review coverage task, we define the list of reviewers to include in the PC and the assignment of suitable review sets to all manuscripts. As this is a novel task, it has not been covered before. And that's why we introduce Diverse, a review assignment and suggestion system tackling the review coverage task. Now that we've finished motivating our problem, let's quickly check the outline of this talk. We will first talk about the method we implemented before we briefly touch on evaluation and then conclude the talk. So, on to the methodology. We introduced Diverse, a diverse review suggestion system for extending conference program committees. It tackles the review coverage task, so it handles both review assignment and review suggestion. The code can be found online on GitHub. Our approach constructs diverse review sets and ensures diversity of the whole program committee. It presents explainable recommendations and review suggestions, and these explanations are directly derived from the properties of the review assignments. So, which properties do review sets constructed by Diverse need to fulfill? There cannot be conflicts of interest between reviewers and authors of assigned papers. Reviewers need to be impartial and cannot be influenced by authors of papers. Reviewers in a set are diverse in their professional background, location, and seniority. For the professional background aspect, sets need to contain at least one reviewer from academia and one from industry. As for location, not all reviewers can come from the same continent. Considering seniority, all reviewer sets should contain at least one senior reviewer. Additionally, we state no dependencies between reviewers in a set should be violated. As dependencies, one could consider currently shared affiliations or recently co-authored papers. When constructing review sets, individual upper and lower bounds for reviewing loads need to be considered. Now let's talk about our approach. we're given a set of manuscripts submitted to a conference, its PC, and a set of possible reviewers to extend the PC with. For example, former authors of this exact conference. The final result of the algorithm is an assignment of reviewers to manuscripts. As for the method, we construct a constrained, flow-based approach. The overall objective is to maximize similarities between reviewers and assigned manuscripts. And the general idea for the approach is to identify submissions, which are likely not getting enough suitable reviewers assigned, and to then extend the PC according to these papers and underrepresented diversity aspects. Our actual algorithm is as follows. We first check if the PC is diverse enough for the assignments and include new reviewers if that's not the case. Then we try to compute the first review assignment. If this fails, and while we are unable to compute an assignment, we first identify possibly problematic submissions, and second, include new reviewers fitting these problematic submissions. When we are then able to compute a suitable assignment, we strive to construct assignments where we drop a percentage of possible reviewers for papers to construct different assignments. And we lastly return the most diverse from these as a result of the approach. The actual assignment process is done by using a flow network. Here, we represent manuscripts and reviewers as layers and model our definition of diversity into the network by also using constraints between layers. Let's quickly check the different layers. The first layer, L1, contains one node. It's the source node and source layer. The second layer, L2, contains as many nodes as there are reviewers. Up next, we have L3, the decision layer. It encodes which reviewer reviews which manuscript. For each reviewer, it contains a node to mark the decision to review a paper, so in total, there are number of reviewers times number of manuscripts nodes. L4 is the diversity layer. It encodes our diversity properties in professional background, location, and seniority. Background can take 3 values: academia, non-academia, and both, thus it requires 3 nodes. Location can take 7 different values, depending on the continent of reviewers. Here we have 7 nodes representing the existence of a continent and 7 nodes representing the non-existence of a continent for reviewers. So in total 14 nodes. Lastly, seniority can take 3 values: junior, advanced, and senior reviewers. Therefore, we will also have 3 nodes. In total, layer 4 contains 20 nodes per manuscript. L5 represents papers. This layer has a node for every manuscript. Lastly, L6 is a sink. It contains 1 node. Now, on to the constraints between the different layers. For the first one, between the source and reviewers, we have upper and lower bounds of flow to reviewers by considering the individual reviewing bounds. The constraints between L2 and L3 prevent dependencies in reviewers and sets. So if 2 reviewers are dependent on each other, they both cannot decide to review the same manuscript. Constraints between decision and diversity layer consist of multiple parts corresponding to the diversity aspects. The first one indicates that flow is only allowed to the professional background nodes, which the respective reviewer has. As for location, flow from one reviewer always goes out to 7 continent nodes. If a reviewer is from a specific continent, it goes to the yes version of the node. If a reviewer is not from a specific continent, it goes to the no version of the continent node. And for seniority, it is exactly as we've seen it with the professional background. For reviewers, only flow to the node is allowed, which encodes their level of seniority. Constraints between L4 and L5 define the flow incoming to a paper as the number of required reviewers for a manuscript times 3 for the diversity aspects. The last constraint between L5 and L6 defines the max flow as the number of papers times 3 times number of required reviewers per manuscript. And with that, we have constructed the flow network. The actual assignment of reviewers to manuscripts is restricted by the diversity constraints and dependencies, which we've seen in the flow network. The decision, who reviews what, is encoded in the decision layer of the network. Now, to maximize our already mentioned objective, the similarities of reviewers and assigned manuscripts are considered. First, reviewers are represented as their authored papers. Then we need to compute vector representations of reviewers and manuscripts, for example, by using TF-IDF or BERT. So now, similarity of a reviewer to a manuscript is computed as the vector similarity between the reviewer and the assigned manuscript. The similarity for a manuscript is the summed up similarities for all reviewers to that specific manuscript. Thus, our objective is to maximize the sum of similarities for all reviewers of the venue. Now that's it for the approach. Let's take a look at the evaluation. In the evaluation, we use two non-publicly available datasets from the same conference named ICTIA from 2019 and 2020. The datasets contain the respective submissions, PCs, and possible reviewers. As baselines, we compare our approach against actual assignments and the current state-of-the-art in flow-based review assignment, peer review for all. We construct sets of 3 reviewers, as this is the number of reviewers and real assignment. We conduct an automatic and manual evaluation of the review assignments and a manual evaluation of the reviewer suggestion part. Now on to the automatic evaluation of the review assignments. We compared reviewer sets from our approach, the real assignments, and the current state-of-the-art approach, which is called peer review for all. We measured fairness, diversity, and dependencies of reviewer sets. Fairness is an established measure, which is calculated as the minimum summed up similarity of all reviewers to their assigned manuscripts. Diversity is a novel measure introduced by us. It represents the diversity in reviewers' professional background, the degree of non-overlapping locations, and the existence of different seniority levels in the set. As seniority levels, we define junior, advanced, and senior reviewers. The last measure which we report is the percentage of dependencies in a set. We consider recently shared affiliations and co-authored papers as dependencies. We found the following. Diverse performs better than the baselines in diversity, and it is better or as good as the state-of-the-art in fairness. The real assignments were worse in fairness. Diverse produced the only observed assignments which prevented assigning reviewers in sets which were dependent on each other. We conducted the manual evaluation of the review assignment with the actual PC chairs of the conferences. Evaluated reviewer sets stem from our approach, real assignments, and peer review for all, the state-of-the-art approach. And we found a trade-off between suitability and diversity of assignments that we see in the picture down below. We also found a general low agreement between PC chairs regarding suitability of reviewer sets. For the reviewer suggestion part, we observed suggested reviewers with their respective explanations. For example, they have a non-academia and academia background, or they're topically fitting for specific manuscripts. We asked conference chairs to rate suitability and explanations for the new reviewers and found a general low relevancy of our suggestions. But when only observing explanations for relevant suggestions, they were considered as useful and convincing. Our ranking of suggested reviews was good, but overall we observed difficulties in suggestions quality assessment. Let's wrap up this talk. To conclude, we introduced the review coverage task and presented Diverse, an approach tackling this problem. Diverse is a review assignment and PC extension approach based on network flow. We evaluated our approach automatically and with 3 PC chairs and came to the conclusion that it produced diverse review assignments for manuscripts. Additionally, we found out that the review suggestion part is difficult to evaluate as experts had low agreements. Future work could extend this approach by incorporating bidding information of reviewers of the original PC or the implementation of stricter diversity requirements. For example, we could restrict suitable reviewer sets as ones which also always include a junior reviewer, or that newly introduced reviewers always have to review at least 2 manuscripts. And yeah, that's it. Thank you for your kind attention.